Hello, everyone, and welcome. I'm Allan Jude, the host of today's webinar. Whether you're joining us live or watching the recording of this later, we appreciate you spending your time with us. For those of you who are new to Klara, we're a team of open source experts specializing in ZFS and FreeBSD, helping companies around the world optimize their systems and tackle complex technical challenges. So you should talk to us if you're looking to build a new or re-architect an existing storage server, get support for or squeeze the most performance out of your FreeBSD or ZFS infrastructure, or if you're looking to develop new features for ZFS or FreeBSD. But back to the webinar. Today's session, ZFS Mastery, the bits they don't put in the man pages, goes beyond what's in the documentation and digs into the insights that only come from having run ZFS in production for many years. We'll be covering some hard-earned lessons from managing ZFS at scale, tuning guidance and operational practices that rarely make it into the manuals, how ZFS design choices have evolved over time and how the advice you heard before maybe isn't valid anymore, and practical stories from real-world deployments that will save you from pain. So feel free to drop any questions you have in the chat or the Q&A system. We'll be monitoring those throughout and answering those questions live. But joining us today is Michael W. Lucas, the co-author of FreeBSD Mastery ZFS and a longtime contributor to the BSD community. So I'll pass it over to Michael to introduce himself.
Hi, folks. I write books on computer stuff for a living. I was a sysadmin professionally for 20 years. I've used Unix since 1987. For better or worse, this stuff is my life. And Allan and I are right now working on a new ZFS book. Yes, I'm from the States, but Klara is Canadian, so I'm respecting their traditions, and it's ZFS for this talk. Thanks, Allan.
Very nice. So getting into things, as mentioned in the intro, we'll talk first about some hard-won lessons, the little things that will often trip you up, and what's the next thing that's going to bite me, and everything you can do to try to be able to sleep better at night. And then speaking of sleeping better, we'll talk about some best practices, making sure your pool remains reliable, and that you're able to sleep and not get on-call pages because nobody likes that. Then, as we teased, we'll talk about the ever-evolving nature of ZFS and how what used to be common wisdom is now wrong advice, and some of the ways that ZFS has changed over the last few years that you will want to keep in mind when reading documentation. And lastly, we'll talk about some of the stories that Michael and I have accumulated over the years that might help you avoid some of the mistakes we've seen others make. So starting off with the hard-won lessons. My biggest piece of advice is label everything. And I mean that in all the different senses of the word. So starting with the device name, when you put a device in your pool, instead of it being, ADA0 or SDA or whatever, you want to use something that's actually uniquely identifying the device. So often that is either the hard drive or SSD serial number, or it's WWN if it's a SAS device, something that's kind of worldwide unique and isn't going to cause a problem with some other device being confused for it. This can get extra complicated. I saw a case recently with I think it was an HP RAID controller, and don't use a RAID controller, but that's for a different part of the talk. And when you made volumes, it assigned them serial numbers based on just like, this is the 7th volume, so its serial number will be based on this blah, blah, blah 7. Meaning if you have 2 of those cards in a machine, in order to access more disks, you ended up with 2 sets of disks with the same serial numbers, and that is terrible, especially when they're not even the same size. This really confuses, in particular on Linux, the UDEV subsystem that creates all these symlinks. When there is a conflict, it might actually just keep flip-flopping the existing symlink to point to different devices. So depending which way it's flipped, when you try to import your pool, you'll get told that that disk is corrupt because it's actually some other disk from some other pool or some uninitialized disk, and it causes no end of problems. So sometimes I take it a step further and when creating a custom name for the device, in addition to its serial number, also include its physical location. It is in enclosure 2 in slot number 7, so that, and it's this serial number, so that I can also figure out where it is. You know, we have the technology to blink the little locate LED, but it's not always that helpful. And also, if the rack is full of blinking LEDs, finding the one red blinking LED can actually be a little more difficult. And if you know, hey, enclosure 2, slot 7, and then you never know what order the enclosure is going to number the slots in, so you still want the LED, but it narrows the search a lot, and that can save you a lot of time. And then, as Michael and I recommended in the previous version of the book, and we'll continue to recommend, actually affix a physical label to each of the hot swap bays with the matching serial number, so that you have to assume it's not going to be you who's pulling the dead drive out of this chassis. And so you want to make sure that whoever's doing it at 3:30 in the morning while sleep deprived and having fuzzy eyes is verifying that this is actually the disk we want to take out and dispose of, and not have them yank the disk that you really needed and throw it away.
Absolutely. I would say in general, label things even more than this, use properties more than we do. Uh, Even at the data set level, if I create a data set, I use a custom property called purpose. And I leave a note for me on why did I need to create this data set? And
Yeah,
and
and why
months
did I
later,
set this setting on it?
yes. Months later, I'll stumble across something and say, oh, that looks like a good place to put the data. And then I see, oh, no, that's a CH root. For this other program, leave it alone. So documenting in ZFS will save you pain.
Yeah, and that gets right to the next point here. A few years back, I added the VDEV property, so you can have custom user properties on each disk. And with that, you can put, for example, the model number, the field replaceable unit number, the part number, the model number, the SKU, whatever, um, or like the date when the warranty expires, or the link to the warranty page, or the link to the URL where you go to buy another one of these drives. If you attach all that to the metadata of the device in ZFS, ZFS stores that pool wide. So even if that disk is dead and you can't get smart to talk to it to find out what its serial number was or what its model number was, you can look in the ZFS properties and be like, oh, it was a this model of this size, and its warranty is not expired yet, so I should go fill out this form and get a replacement drive. Or the warranty was already expired, we need to just go buy a replacement, and here's the URL. It really makes it easier to do that cross matching we talked about to make sure you're ordering the right kind of replacement drive, that you're swapping the right physical drive, and all those things. It really does make a big difference for getting things uh, going the way you would like them to. So moving on, Michael, you have some tips for us.
I do. The biggest tip that I see people stumbling into is thinking that ZFS is just another UFS or EXTFS with really cool error correction. And you can use it that way, but you are limiting yourself. Some tools like DF and monitoring inodes and such just don't apply anymore. Um, you're better off thinking of ZFS not as a file system, but as a set of tools for managing data. It's a whole mindset change, but it's like leaving a two-dimensional world to go into a third dimension. And all the possibilities multiply. And I think the best example I have of this is twice now. People have mentioned to me that they had a problem because they could no longer dump ZFS file systems on FreeBSD. And the first time someone said that, I said, wait, that ever worked? You could do that? Um, Apparently, there was a time that you could, and it seemed to work. However, that's not how you're supposed to use it. And use the tools meant for ZFS on ZFS because it is fundamentally different. Um,
Yeah, like I saw exactly this even earlier this week. Somebody was like, I did zpool list and it said I had, so many terabytes of free space. But when I try to write a file, it says I'm out of space. What's going on? Uh, and the first thing I say, well, zpool list isn't the right place to look because the amount of free space it lists includes the space reserved for the parity and so on. Uh, but it turns out this person was using mirrors, so they didn't have as much of that problem. But when we look at ZFS list, we see that yes, they are indeed out of space, or very close to it. They were trying to create another ZVol, and the ZVol they wanted to create was bigger than the amount of free space they had. So it was saying, hey, there's not enough space for that. Upon a little more digging, it turns out some other ZVol they had created in the past was 500 gigabytes, which is fine, but they didn't mean for it to be 500 gigabytes. They meant for it to be 50. And because it had a reservation on 500 gigabytes of space, but wasn't using it all, it meant that all that space was actually free, but was reserved for that VDEV or that ZVol, and so they couldn't use it. So a little fiddling and kind of changing the reservation on that one ZVol down to just 100 gigs or 50 gigs or whatever they wanted meant that suddenly they had space and could use their file system again.
oh, yeah.
It,
Yeah, you have to think different. There are new failure modes to go along with the new possibilities. One of the things that I've found really helpful is there's a toolkit called Zelta that will let you automate a lot of ZFS operations very easily. Things like take all the snapshots that exist on this system that are not already on my other system and send them over. So if you throw a lot of ZFS around the network, I would tell you to look at Zelta. And then to touch back on Allan's story about a pool being out of space, recovering from a ZFS file system that is actually full is very difficult. I would strongly recommend you reserve about 10% of each pool just for disasters, just so you have a warning in case your pool is about to be full, because it's much easier to hit that limit, turn the limit down to 5%, and order more hard drives or clean up old data than it is to recover from a pool that is actually 100% full.
yeah, and also just the performance of that last 0.5% when it's full, it can really degrade things and make things feel pretty bad. Uh, but
Yes.
as we've seen, especially like literally right now, hard drives are starting to become in short supply. There's more demand than there is supply. That means if you go to order some more hard drives to expand your pool, there might be a 6 to 8 week delay before you actually get the drives. If that's the case, then you're going to really wish you had gotten the warning that, hey, we're 90% full. I'm going to unlock a little bit of space to let things keep going, and I'm going to encourage people to clean up the stuff they don't need while I wait for those hard drives to come, instead of being like, oh crap, we're out of space and the hard drives aren't coming for another 2 months. What are we going to do?
Right. Uh, just because ZFS seems like magic doesn't mean it can make more storage appear. At one point, uh, in desperation many years ago, because I couldn't get more storage in a system, I had to split a Z RAID and pull a parity drive out of several to build a new little array for emergency storage. And I sweated blood for a week. Uh, Try to never do that. That your life is worth more than that. And I would say definitely my last big tip is to always check for the new way of doing things because ZFS does evolve. Um, Several years ago, I had to move uh, several terabytes of data across a really lossy network. And I was moving at a data set at a time and crossing my fingers that the connection would stay live. And I griped about this out on social media, and I think it may have been Allan came back and said, did you know that ZFS send can now be resumed? And you just have to add these flags and it will pick up where it left off. And that reduced my pain immensely. So someone else has had your pain. Check to see how it's been solved in the last couple of years, because there may well be a solution now.
Yeah, and that last couple years part is important. We have a whole section of this webinar specifically on, some of the things that have changed out from under you. And, if someone tells you this is the way to do it, it probably was, but it's not necessarily anymore. And I had a similar experience with the ZFS send receive with resume, in that, the feature didn't exist when I needed it. I was moving a large data set from Canada to Australia, and it was like 400 gigabytes or something over a 1 gigabit connection. And it would get to about 300 and something gigabytes, and then the SSH session would hiccup and drop. And I was getting very annoyed at it. Uh, and then at the next conference I happened to go to, Matt Aarons was talking about, hey, we built this resume feature for ZFS, and I'm like, when can I have it? Can I have it yet? Can I have it yet? Can I have it? And so once I had it, as you mentioned, I was just kind of maybe evangelizing it quite a bit, trying to make sure that everybody knew that, hey, we have this great new capability, and it will literally save you from untold pain, if you're trying to move a large data set over a network and it keeps getting interrupted.
And there's changes like yep, ZFS now has the native encryption, so
Mhm.
you can do it that way instead of geom and move your encryption between your pool between hosts more easily. Just there's always something new. The
Yeah.
There's ZFS rewrite in the newest, which would have saved me pain before.
Yes, but I remember we corrected the man page just the other day. It doesn't help if you want to change the record size, though.
Oh,
But it can, for example, get rid of dedupe or get rid of gzip if you happen to have written everything using gzip and regret your life choices. So moving on to some best practices. Uh, the first thing is consistency is key. And when you're doing things, you want to do it the same way that you always do it. And you want to make sure the way you always do it is the right way. And you're doing it that way every time. It's the little one off, oh, I'll just try this. And then I forgot that I did that. And so on. That's the thing that's going to come back to bite you. Nothing worse than setting a trap for yourself, where it's like, oh, I'm going to set this setting and I'll remember to turn it off later, and go back to what it was supposed to be. And then it doesn't actually work. As Michael mentioned a few minutes ago, you want to write everything down. Document not just how you did things, but why.
why?
And some of that documentation, it may make a lot of sense to keep in line in ZFS itself, right? Putting on a data set, this is why we set compression equals Z standard 19, even though it's really slow. It's like we only write this data once and we'll read it many times and it's worth it. But not only do you want to write that down, in the documentation somewhere, but you can embed that in ZFS with the user properties so that it's always there for someone to find it. Or, because there's only so much room in those properties, although they can go up to like 4 kilobytes. So it's not like you're going to run out of room to put a couple sentences. But one of the things the property could be is the link to the documentation that explains, you know, the complicated reasoning behind this choice rather than trying to embed paragraphs into your ZFS properties. Uh,
And if you hit 4K in your property, maybe you need to break that property up into more specific properties.
yes, or make it a reference to somewhere else where you actually store that amount of information. But one of the really important things, especially for being able to get support with stuff, is you want to write down all the steps you performed and their output, and as much as possible, what it looked like before and then after. A mutual friend of ours, Dan Langill, often does this. Basically, he has his own blog, and he just happens to blog. This is what it looked like before. These are the commands I ran, and the output it happened, and this is what it looks like after. And by keeping those notes, when he's run into a problem, it's possible for someone to look at, okay, this is what happened. I see right there that message. That means that it didn't do what you wanted it to do. It did this other thing. Or because of what you've changed, we see this is what happened. And just having that bit more context makes it much easier. Come into many support cases where it's like, well, we don't remember exactly what we did. Or I think vaguely it said something about this, and we just kept continuing and then, went on. ZFS has a history command, so zpool history keeps a list of the last couple thousand commands that have been actually changed something in ZFS, and it's like who did what to what data set and at what time. But it's a ring buffer, so it gets overwritten as over time, and it means snapshots can quickly fill up the history with just creating and destroying snapshots all the time and so on. But it never explains why someone ran the command, only what command they ran. It also doesn't specify what they were trying to do. We can talk about horror stories at the end later, but the command you ran doesn't mean that it was a command you meant to run. And that makes a big difference.
Absolutely. And Dan is a treasure, and so is his blog. If you are running ZFS, you should subscribe to his blog. And everything Allan said is right. My test lab is tiny, but I still use Ansible to make sure everything is set up correctly. I use scripts for installing things that I have to do even twice. I'm setting up a bunch of Debian systems or Debian for the new OpenZFS book. And so I have a script I can download that will do the Debian ZFS install dance for me. And I may tweak it now and then, but it's still the same way every time. I know I didn't miss anything. Automate consistency, monitoring.
Yeah, for sure. Especially when you're writing a book, you don't want to end up with, oh, halfway through the book, I forgot a step, and so changed the configuration of the machine I've been doing all the output from, and now the book is inconsistent, and I have to go back and do all the examples over again.
I'm
Ask
sorry.
me how I know. But yeah, to Michael's point, if you're making snapshots and they're not being created automatically, then are they really happening? You know, if you're setting up replication, but it's not automated and it's not monitored to make sure it's still happening, is it still happening? And yeah, keep a record of what happened, what it looked like before, what you changed, what it looked like after, and that can be the difference between a quick fix and an all-nighter. It really does make a huge difference. So somebody in the questions asked, is Zelta recommended over Sanoid or Syncoid, or is it just a different tool for doing the same thing? They are not exactly the same. In general, they're doing about the same thing, but Zelta is a little more focused on the case of recovering from things like ransomware, where you're going to want to set up a clone of the damaged file system and then restore the undamaged one rather than just do a rollback. So it's maybe a little bit more on the MSP use case, whereas Sanoid and Syncoid is a tool for sysadmins. Zelta is a tool for sysadmins, but for servicing users at with more compliance issues and so on. But they both work very well, and whichever one you're more comfortable with is probably fine.
Um, just had a thought, because if you're keeping warranty dates
Mm-hmm.
in properties, you could have your monitoring system flag you when a drive goes out of warranty.
Yeah, or when it's 30 or 60 days before its warranty is up, being like, hey, it's time to order that replacement because it might take 60 days to come, and make sure that your drives are always running within warranty so that if they fail, you're not stuck with no drives.
Yes. Yeah, try that with UFS and see how far you get. Actually,
Yeah,
we had a way to do that. It was called spreadsheets and check them
yeah,
once a month, which we never did.
yep. So yeah, a couple more best practices, maybe not quite rapid fire, but the first one is test your backups, right? The whole point of taking your backup regularly is making sure that you can restore. If you've never tried to restore, you don't know if you have a backup or a waste of time.
There's
Uh,
nothing like Schrodinger's backup.
yeah.
The backup doesn't exist until you look.
And then you want to look and make sure, does the backup actually contain everything you need? Because we've seen things before. It's like, yeah, we have backups of all the VM disk images and everything, but we don't have current versions of the config file.
You,
So which disk goes with which VM, or how much RAM was that VM supposed to have? All of that can really bite you. Another big one is the two-person rule. Before you take any destructive action, you want a second set of eyes to make sure that command does what you intend and is safe. That second person could just be a workmate, or it can be somebody from Klara under your support subscription or whatever. But making sure that someone else is double checking that. Nothing worse than pressing enter, reading what you wrote, and realizing that didn't do what I wanted. Happened to me recently. Trying to just chown some files in a directory, and I I missed the slash and hit enter, and chowned stuff in slash bin to my user instead of root. And then when that happens in slash lib, SSH doesn't work anymore. Have fun with that. Uh, Next thing is you want to operate on least privilege. Uh, so ZFS has delegation. You can do ZFS allow, you know, Lucas to do foo. And this allows you to, rather than having to sudo everything you want to do with ZFS or be root, you can say, hey, this happens as an unprivileged user. This can be especially important for replication. If you're going to, have some other machine reach in and pull a copy of your data, or you're going to be pushing a copy, you want to make sure that that backup is done by a user who can only read the files they're supposed to be able to read, only back up the right things, and that they don't have the ability to destroy data sets in case someone manages to compromise that account, and so on. So it allows you to break things down, and this user is allowed to take as many snapshots as they want, but they're not allowed to destroy any snapshots. The automatic reclamation system can do that, or whatever combination that happens to be. In ZFS 2.4, there's a new feature where you can allow such a backup user to only be able to do replication of encrypted data sets.
ooh,
So if you have encryption enabled, when you go to do a ZFS send, if you don't include any extra flags, it will decrypt the data and send it in clear. Or if you set the raw flag, it'll it'll replicate the encrypted version. If your backup is going to an untrusted offsite, you probably want that latter option. And you want to make sure that even accidentally, somebody doesn't send the wrong version. And so delegating it so the backup user can only read the encrypted copy of the data, not the decrypted copy, will let you do that.
and as the author of the book on sudo, ZFS is the right place to configure this. Don't even try in sudo.
Yep. The next one is checkpoints. So there's a feature in ZFS called a zpool checkpoint. You're only allowed to have one of them, but it basically saves the Uber block from the last transaction group and disables the reuse of space. So any block that's ever written will not actually get freed. It'll just be unused. Um, and this allows you to undo anything that happens after that. This was designed for an appliance upgrade use case where they were going to rename a bunch of data sets and create new data sets. And if the upgrade script failed in the middle, it was going to be a real pain to try to undo only the things we've actually done and so on. So they took a checkpoint, ran the script. If the script failed, they would just roll back to the checkpoint. And this is probably exactly what you want to do if you're about to make some changes. If you're going to add a new VDEV and you're worried you might accidentally fat finger it and do the old classic thing of adding your log device as a regular storage device or something like that. Or you're going to delete some data sets and you want to make sure you're happy with the result before you commit that. Or whatever else like that you might want. So create a checkpoint before you do anything, whether that's a zpool upgrade, adding a new VDEV, changing anything significant about the pool, or even destroying some data. And then if you're happy with it after a day or so, you can discard the checkpoint and it didn't cost you anything. But having that checkpoint to be able to undo whatever it is you just did can make a huge difference. Uh, Although the one caution is you don't want to keep the checkpoint forever because, as I mentioned, it disables the reuse of any space. So while, normally with copy on write, as you change stuff, if you don't have a snapshot, it would eventually reuse that space for some other block. But with a checkpoint, it won't do that because it needs to save everything to be able to go back. And so you can very quickly run out of space entirely. But, you know, the checkpoint is meant to keep around for a day or two just to make sure whatever big change you made is okay before you commit to it. And then lastly is don't use the root data set. This was a mistake that we made about 25 years ago when ZFS was started, that the data set that happens to have the same name as the pool, so just the pool name, is a data set that you can mount and put stuff in. We shouldn't have done that. You can't rename that data set. You can't do a bunch of other things with it. Encrypting it isn't really possible, and everything inherits from it. And so even restoring it via replication isn't easy. You kind of have to force overwrite the whole pool and so on. So making that a usable data set was a mistake. So just leave it empty. Don't mount it. Set a mount point somewhere and set cam mount off, whatever, and make data sets for everything. Don't just use the root of the pool, please. So next up, I wanted to quickly mention if you're finding this information valuable and you would like to learn more about ZFS, head over to Klara's ZFS Basecamp. It's our centralized learning resource for about ZFS. It has articles, past webinars, and we'll include this webinar in the next couple days. Has white papers, case studies, everything you ever wanted, and it's organized by what you know about ZFS. So it has a section for people who are just getting started and want to know what a VDEV is and what a log device is and why would they would want a log device. And then it's got, you've convinced me, I'm going to build ZFS. How do I decide what to do? What are the first steps? What information do I need to establish before I get started? Uh, and then it gets into, all right, I have a ZFS system. How do I tune it? How do I make it better? How do I monitor it and make sure it's good? How do I keep everything working? And how do I solve this problem I'm having? And then lastly, how do I back it up? How do I do a disaster recovery? How do I do HA? Everything you might need to know about ZFS, all in one place and organized by where you are in your journey through learning ZFS. So speaking of a journey, ZFS itself continues to evolve, and we'll talk a little bit about that. So the first thing is back in 2015, the default compression mode changed. It used to be LZJB, the JB standing for Jeff Bonwick, who is one of the co-creators of ZFS. But it turns out LZ4 can compress better with less CPU. So the default for compress equals on switched from LZJB to LZ4, and it was better. And then think it was about 2021 or so, we also changed the default to actually be compress equals on. So when you create a new pool, compression is now on by default because LZ4 is so inexpensive that it's an exception if you need to turn it off rather than by exception turning it on. But back in ZFS 2.0, we added Z standard support. Uh, any data that LZ4 is managing to compress about 2 to 1, Z standard will probably compress that same data to 3 to 1 or more, meaning it takes that much less space. And Z standard includes, well, 19 different compression levels to let you kind of slide the scale of how much CPU time I want to trade off for how much compression. Plus, it has the Z standard dash fast scale, which adds another 20 or so compression levels to uh, err on the other side of I'd want to get any compression I can get for free, but I don't want to spend a lot of CPU time on it. But the problem is not every file compresses. So if you're using, Z standard 10 or 15 or 19, that can get pretty expensive if a certain file doesn't compress. So uh, Z standard, we added the early abort feature, where basically it will quickly try to use LZ4 to compress a block. If it compresses, then it will do the heavy Z standard compression on it, the high level one. But if LZ4 can't compress the block, we know Z standard probably won't be able to either, and we'll skip it. And this way you can get the advantage of having compression turned up high, but without paying all of the cost in exchange for a little bit of a litmus test before you start. It will avoid trying to compress uncompressible data, but still really compress all your compressible data. So at this point, there's never a reason to use gzip ever at all, except for maybe if you have a quick assist device that offloads gzip, but that has its own whole set of problems and only is efficient at a certain range of block sizes. If your blocks are too big or too small, then it doesn't make sense. And there's just too many caveats for that to be general advice. Another thing that's changed significantly recently is the prefetch system in ZFS. It's gotten smarter, it scales better, and it only prefetches a large amount if it's actually going to be useful now. So before ZFS 2.2, if you set your primary cache to metadata or even to off, that in addition to not caching the files that you were reading and writing, ZFS would also not be able to prefetch because prefetch is about populating the cache with the data it guesses that you're going to want next. And so if the cache was off, then it wouldn't be effective. But with 2.2, they've added the uncached prefetch feature, which actually allows that data to go into the arc, but only for a couple of seconds. And if you use it or don't use it, then it will get evicted eventually, but allows ZFS to track it and make sure it doesn't just get stuck in memory or that we don't throw it away immediately, having made a waste of our time to prefetch it. Another big enhancement in 2.3 is you can now control prefetch on a per dataset basis. So on each dataset, you can turn prefetch on and off instead of just having one system-wide tunable. This can be a big difference for mixed workloads where, for these workloads, yes, prefetch is good, let's have it on. But the database always reads randomly and prefetch will just be bad. It'll waste IOPS, so we'll turn it off for that one dataset. And that can make it much easier to kind of tune how much you're prefetching. But the new algorithm is very smart where it prefetches a little bit, and then if you happen to use that little bit in time, then it will keep incrementing the amount it does by a little bit at a time. And every time you successively make that work, it will then increase the size up to where it's, reading, tens or more megabytes ahead of you in order to make sure that every time the application's doing the next read, that's coming from the cache and is as fast as possible. One of the biggest changes is that dedupe isn't terrible anymore. Lucas and I have spent about 15 years telling people that don't use dedupe. It will just lead to pain and suffering. The way dedupe worked before meant that, every write involved random reads and that would slow things down a lot. And the amplification meant that if you wrote out 600 gigabytes of data with dedupe on with a smallish record size. You might actually end up writing over 2 terabytes to the pool, not using 2 terabytes of space, but just overwriting the same blocks over and over again as the indirect blocks, and the dedupe table itself got rewritten over and over and over and over, and it was very inefficient. But working with the folks from TrueNAS, Klara introduced the fast dedupe feature, which includes solutions to basically all of the common problems with dedupe. The first was you can now set a dedupe quota, which is the limit on the amount of memory that dedupe is allowed to use for its dedupe table. So as that table gets too big and hits that quota limit, we will stop adding new entries to it. So any hash that's already in there will continue to dedupe, but we won't add new ones because we don't want to get to the point where that table is too big and causes all the problems people ran into before. But that limits the effectiveness of dedupe if, it's full and we can never dedupe anything new. So we added the prune feature, which can go through the dedupe table and find, blocks you added 3 months ago and have never found a duplicate. Those probably are not going to find a duplicate today either. So we can remove those because the new block you write today is likely that in the same day is when you're going to find the duplicate of it. And so that lets you balance the dedupe table and get most out of it. And the big change was changing the DDT to have a log so that we could reduce that amplification. And now, if you were, say, writing out that same 600 gigabytes of data with an 8K record size, the writes to the dedupe table will be about 50 gigabytes instead of 1,200 gigabytes. That's a huge savings.
Yeah, it's not magic. It's not the magic that we want it to be. But you can actually consider using it now, and it might actually be a sensible choice.
Yeah, it's no longer actively harmful.
Yes.
Worst case now, it just won't help you at all. It won't make things terrible. So before we run out of time, we promised to get to some insider stories. So the first one here was about mismatched block size. This one was a company that was building a backup system where they backed up the entire hard drive of Windows machines. And the way they would do this incrementally was to then copy a whole new image of the hard drive over top of a ZFS copy of the drive, where they used the not write feature. So in ZFS, there's a feature if you're using a strong enough checksum, when you write a new block, if the checksum is the same as the block that's already on disk, ZFS knows it doesn't need to write it and just skips the write, making it go really fast. The problem was they were writing these files over NFS with a block size of 64K, while ZFS was configured with its default record size of 128K. So that meant every time they wrote 64K, that would be a sub-block update. So ZFS would have to read the whole 128K block, calculate the checksum and make sure it was right, then take that 128K block, merge in the 64 you just changed, calculate the new checksum, go to write it out, see that it's the same as the existing checksum, so do nothing. Then, over NFS, we would write the second block. Because the cache was turned off, we would read the whole 128K block and check its checksum. It was good. Update the second half of the block, calculate the new checksum, see that that matches what's on disk, and do nothing. So in order to do nothing with the 128K of changes, we read that same 128K twice, calculated the checksum a total of 4 times, and did 2 mem copies, all for nothing. Just because those block sizes were not aligned. Changed the ZFS record size to 64K, and suddenly the system was blazingly fast. Michael, you want to tell us your story about tiny files?
Sure. Oh, yeah, I'm sorry. I'm looking at my notes, not the slide. I'm sorry. Okay. I used to work for a phone company, my last straight job. And some of the most precious data a phone company has are CDRs, call data records. And these were tiny things, but but they are precious and they must be saved. And the billing people analyze them, absolutely vital data. And each of these files, they're just plain text, and they came to about 5 or 6K. So you buy the big fancy storage array. RAID Z3. And unfortunately, RAID Z3 makes each allocation about a minimum of 4 blocks, 1 for the data, 3 for parity. So if you have these tiny files that are 2 allocations, these 5K files wind up taking up 32K of disk. And so your 10 terabyte array can store 1.5 terabytes of data. And this is suboptimal. So you have to consider how your data interacts with ZFS. And this might seem contrived, but if I look at the photos directory on my desktop computer, each of those photos is about 4 to 5K. So, and ZFS does not do the same kind of fragmentation you might expect from UFS. Fragmentation in ZFS is about how the data is arranged, not partial blocks. So the way around this is to buy drives that have 512 byte blocks. But then you have the question, is this drive really doing 512 byte blocks? Or are they writing 8 times to the same 4K block? Because hard drives are lying liars that lie. And kind of similarly, the default vol block size in ZFS is 16K. If you have a new NVMe drive like Allan had that had these 32K blocks, you only use half the space. So there's lots of ways for ZFS to give you less disk space than you expect. And you have to watch out for these things and watch out for weirdness in general.
Yeah, we saw a kind of related case where a customer had new NVMe drives that happened to have 32K sectors. So that means the smallest block you could write to it was 32K. And ZFS detected that and did the right thing in ZFS. But then they created a ZVol with a vol block size of 16K, which is the default, for their VM to live on. And they created, a 500 gigabyte VM image thing and started writing to it. And they were using it for a while. And then eventually, one day, their pool was completely full. And they're like, how is our 1 terabyte pool full if we only have this 500 gigabyte of data on it? Well, if every 16K record is actually expanded to a 32K sector, because that's the smallest sector you can have, then your 500 gigs of data actually takes a terabyte space. And so they didn't actually manage to fill their ZVol because they ran out of space in the backing pool because of this mismatch between the block size. In their case, it wasn't because of parity, it was because of the sector size of the disk, but it can be effectively the same thing. So yeah, as we summarize, I also want to take a moment to ask everyone to let us know how you heard about this webinar so we can make sure that you hear about the next one. So basically, not everything can be written down. In particular, the answers to a lot of questions are, it depends. And it's really hard to do that in the documentation. And so sometimes it's better not to recommend a setting that works only 50% of the time, because for the other 50% of the people, it'll be the wrong answer. So what is the right record size for my workload? Can't really document that because there are 100 different answers. Will a large L2 arc make my pool faster? It depends. If your working set is just a little bit larger than your RAM, probably. If your working set is really small or really large, and then you're just wearing out an SSD for no reason. Why does my system seem slow? It's like, well, that's going to take an expert analysis to figure out. We can figure it out, but your answer isn't going to be the same as Lucas's answer. The common answer is not always the best answer. Every pool is different. Every user is unique. Every application is doing some fresh kind of evil that is causing the problem. And so, whether you're editing video or saving scientific research or just streaming some video, the answers for your case will be different.
I keep telling people that the first rule of system administration is that computers were a mistake. And there's an infinite variety of mistakes. And you've got to dig deep.
Yep. So Devin had a question. Any tips for monitoring snapshots or replication, specifically tools that you use, integrations with existing monitoring stacks like Prometheus and Grafana and so on? For my case, we make sure the name of the snapshot has a timestamp in it. And then on the receiving side, we use the latest snapshot and the difference between that timestamp and the current timestamp to tell how far behind we are. And we have a graph of that in our Prometheus. And basically, we set off an alert if that gets more than a few hours behind, whatever our tolerance is. It depends what our recovery point objective and recovery time objective are. But in some cases, like, if it's within half a day, we're fine. And sometimes if it's more than an hour, there's a problem. It really depends on how far you're replicating, how fast the link is, how fast the data churns, and so on. But yeah, you want to be looking at the basically how far behind the snapshot is, and is that supposed to be like that? Uh, the other thing, a tip I learned is you should put the host name or some short identifier of the host in the name of the snapshot so that the same snapshot created on two different machines won't have the same name. Uh, in one case, it turned out the machine receiving the backup was accidentally creating snapshots in the dataset at exactly the same time, on the minute every 15 minutes. So it looked like the data was being copied, but it was snapshots of an empty data set, and the replication wasn't working because it's like, well, there's a snapshot with that name already there, but it's not the same GUID, so it's not the same snapshot. Do you have any advice, Michael, to add?
No, I think you've covered it. And you have far more ZFS than I do, so I bow to your wisdom.
Yeah, but I'm sure you've fought with monitoring systems
Oh,
lots.
monitoring is terrible. There is no good solution. Um, it's also absolutely necessary. You take your best effort and stop worrying about it until you discover a new failure.
All right, I think we're at time for today, but thank you everyone for coming, and we'll try to get some more of these questions next time. And thank you to those who answered our survey. Please continue to do that if you'd like. And we'll look forward to seeing you next time. And definitely reach out if you'd like ZFS support for your system. And watch our website for our next webinar, where I think we'll be talking about the 12 days of Christmas around ZFS in December to talk about some of the new stuff that's coming.
Thank you all, and thanks for the invite, Allan.
Yes, thank you for joining us, Michael. Oh, and Michael, you wanted to let people know about the new version of the ZFS book that's coming out,
Yes,
and how to get your name in the back of the book.
this book is open for sponsors. If you go to sponsor.mwl.io, you can get your name in the back of the ebook. You can get it in the back of the print book and make me and or Allan, depending on logistics, sign a copy and send it to you. And that will help us create the book. Because Allan here has a real job. He answers the phone. I just write silly books. So sponsor.mwl.io. And if you feel like helping us out, that would be great.
Okay. Thanks everyone for joining us, and we'll see you again next time.